In this video we're going to finish up section 2.2, which covers functions. So we'll pick up here with example 5, and the directions say find all real values of x such that f of x, the function, is equal to 0. So the first one here, we're going to take this f of x and turn that into a 0. So we have our f of x is equal to the function minus 2x plus 10. And now we're going to replace the f of x with a 0. So let's set that equal to 0. And now we solve for x. Step 1, subtract 10 from both sides. Next, divide by negative 2. So we get x equals, the negatives cancel. 10 divided by 2 is 5. So we found this x value of 5. And if we think about it, this is the x value that should give us an overall function value of 0. So if f of x is this function, let's find f of 5. So we're going to have our negative 2, replace our x with the 5, and add 10. Negative 2 times 5 is negative 10, and plus 10, that does in fact give us an output value of 0. Alright, let's check out letter B. Letter B, our function is f of x, and that is a quadratic. X squared minus 5x plus 6, and we're going to set the function equal to 0. And we did this already in section 1.4. The only difference now is we're changing up with this function notation. F of x is our function value, the output value, and we want to find the values for which it is equal to 0. So we're going to take this quadratic and factor it. The factors of positive 6 that add up to negative 5 would have to be a negative 3 and a negative 2. And then, of course, we take turns, setting first the first factor equal to 0 and getting x is 3. And we set the second factor, x minus 2, equal to 0 and get an x value of 2. So our answers here are x is 2 and x is 3. And we can always check those, and just to reinforce what we actually did here, those are the x values that should give us an overall function value of 0. So let's check f of 2. Plug in a 2, 2 squared minus 5 times 2 plus 6. Well, 2 squared is 4, minus 5 times 2 is 10, plus 6. 4 minus 10 is negative 6 plus 6, and if we add those, we do in fact get a 0. So it did work. We don't have to check these solutions. They should be right, but we're doing it just for a little extra fun. And then f of 3. F of 3 would be 3 squared minus 5 times 3 plus 6. 3 squared is 9, minus 5 times 3 is 15, plus 6. Well, 9 minus 15 is negative 6, and negative 6 plus 6 is 0. So we found the values for which the function was equal to 0. Remember, these are members of our domain that when we run them through the function, give us an output value of 0. So let's see here, example 6. The directions say, find the values of x for which the f of x function is equal to the g of x function. And then they tell us the f of x function is this, x squared plus 1. And the g of x function is this, 3x minus x squared, and we want to find the values for which they are equal. So let's solve this for x. So the first thing I'm going to do is get rid of this negative x squared by adding it to both sides, and now I have 2x squareds on the left. Let's subtract 3x from both sides, so minus 3x. And then we have this plus 1, and now it's equal to 0. So we have a quadratic equal to 0, which means we're going to factor. 2 is a prime number, so that has to be 2x and x. 1 is also, the only factors are 1 and 1. And then we just got to figure out the signs. Our middle term is minus, and this is a plus. Well, if we add two negative things, we get another negative thing. And if we multiply two negative things, we get a positive thing. So these are both negatives. And we continue by setting each factor to 0. 2x minus 1 equals 0. I'm going to add 1 to both sides and divide by 2. X is 1/2. And the other solution is given by the second factor. X minus 1 equals 0 means x equals 1. So our answers are 1/2 and 1. And you know what this is telling us is that we should be able to plug 1/2 in for any x. This would be 1/2 squared plus 1 equals 3 times 1/2 minus 1/2 squared. So 1/2 squared is 1/4 plus 1. Does that equal 3 times 1/2 is 3/2 minus 1/4? So 1 plus 1/4 is 1 1/4, or 5/4. Let's get a common denominator here. That 3/2 is the same as 6/4 minus 1/4 is 5/4. And the same should also work for x values of 1. 1 squared plus 1 should equal 3 times 1 minus 1 squared. That's a squared, trust me. 1 squared plus 1 is 2, and here we have 3 times 1 is 3 minus 1. 3 minus 1 does in fact equal 2. And again, we don't have to check these. You know, you can on a test or a quiz in your homework just to make sure your answers do in fact work. You know, if you do make a mistake, that is one way to catch it. The next one will be a little trickier. We're just setting f of x equal to g of x. So we're going to set these two functions equal. All right, let's get everything. I prefer put everything on the left here. So let's add an x squared. This becomes a 2x squared. There is no x term over here, but we can subtract x from both sides, and now we have a minus x. And then we subtract the 2 out of here. -1 minus 2 more is -3. And that's equal to 0. Again, leading coefficient is greater than 1, but the first and last numbers are primes. The only way to get 2x squared is 2x times x. The only way to get 3 is 3 and 1. Now remember, whatever we put over here is going to be multiplied by 2 and doubled. So if I put the 3 over here, I'm going to get a 6. And that's pretty far away from the -1 we want in the middle. So more than likely, I'm going to have a 1 here. And, oops, not a 2, a 3. The signs are both negative. So let's see if we could play around a bit. It looks like a negative and a positive. And let's check our middle term. The outers multiply to 2x, and the inners to minus 3x. 2x minus 3x is -1x. So there's our middle term. Our factors are indeed correct. Let me move this up. And now we're setting each factor to 0. 2x minus 3 equals 0. I'm going to add 3 to both sides. 2x is 3. And divide by 2. X is 3/2. On the other hand, we know that this factor could also be 0. X plus 1 equals 0. Means x is -1. And you could take the 3/2 and plug it in for these x's and solve it, and it will be equal. Or you could do the same thing with the -1s. And of course, it's going to work. Now let's talk about domain of a function. So the domain of a function can be described explicitly, or it can be implied by the expression used to define the function. The implied domain is the set of all real numbers for which the expression is defined. For instance, the function given by this, f of x equals 1 divided by the quantity, x squared minus 4, has an implied domain that it consists of all real x values except 2 and -2. These two values are excluded from the domain because division by 0 is undefined. So an easy way to figure out, where we have numbers that are not in the domain, if you have a rational function, a fraction where you're going to divide, you want to take just the denominator and set it equal to 0, because that's what we don't want to have happen. We don't want x squared to minus 4 to equal 0. And if we solve this, we can add 4 to each side. X squared equals 4. And then we can extract our roots by square rooting. And we get x equals plus or minus 2. And remember, we're finding out the numbers that we do not want. So our domain would be x does not equal plus or minus 2. Or we could say x is all values except plus and minus 2. Another common type of implied domain is to avoid using or having even roots with negative numbers. And we've talked about this in this class before. For example, this function here, f of x, is the square root of x. is defined only for x's greater than 0. Remember, if you got a radical, take what is under the radical and say that must be greater than or equal to 0, because you never want a negative under an even indexed radical. So there is our domain. We can only plug in x values greater than or equal to 0. Otherwise, we have a negative under a square root, and that's a bad thing. So the implied domain is all numbers from 0, including 0, that's the bracket, all the way up to infinity. In general, the domain of a function excludes values that would either cause division by 0 or result in an even root of a negative number. And we did talk about that earlier in this class. I think it was in Chapter P. So that is kind of like a refresher there. So find the domain of a function. In letter A, here's f is this, and we have our set of ordered pairs. So remember, when we're finding the domain, it's just the x values of an ordered pair. So we could use our brackets here. What numbers here are in the domain? -3, -1, 0, 2, and 4. So we just write them in order with commas. -3, -1, 0, 2, 4. There's our domain. Those are the inputs to this function. If they asked us for the range of the function, we would just do the y values. Every domain number is paired up with a range number. All right. Letter B. Our function, g of x, they're calling this one, is 1 over x plus 5. So what is the domain? Or more importantly, what numbers are not in the domain? We have a fraction. Remember, you do not want to divide by 0, so let's set the denominator x plus 5 not equal to 0, because that's what we do not ever want to have happen. To solve for x, subtract 5 from each side. X does not equal -5. All other numbers are in the domain. -5 is the one number that if you plug it in for this x will cause a divide by 0 scenario. And we don't want that to happen. Now this next one. This is just a little kind of common sense. The volume of a sphere. Volume equals 4/3 pi r cubed. Now we got to think, r, what does the r stand for? Well, r is a radius. So if we have a sphere, our radius emits from the center of the sphere, and it goes to the edge of the circle. So let's think about a radius. A radius is a length. When we measure something, how do we measure length? Or can we ever have negative length? Can you pick up a ruler and measure a piece of notebook paper and say the side of that notebook paper is negative whatever? No, length is always positive. So here, if we're talking about the volume of a sphere, and V is our output, as we plug in numbers for r, as the radius changes, the volume will change too. So this is our independent variable. What numbers can we plug in for the radius? Well, only positive numbers. It just makes sense that our radius must be greater than 0. You can't have a negative radius. If you have a negative radius, to the third power would be a negative, and that would make this whole side negative, and that would result in a negative volume. You have a 1-gallon jug of milk in the fridge. Is it possible to have a negative gallon of milk in the fridge? No, it just doesn't make sense. Letter D is a radical. It's a square root. It's an even root. Remember, we never want a negative to occur under an even radical. So we're going to take just what is under the radical and say that value must be greater than or equal to 0. And let's see here, let's add 3x to both sides. So we're going to have 4 is greater than or equal to 3x. And then we're going to divide by 3. 4/3 is greater than or equal to x. If you approach this the other way and you subtracted 4 from each side, we would get -3x is greater than or equal to -4. Remember, when you divide by a negative, you got to do something special. What is it? Divide by a negative, and these negatives will cancel, and you'll get 4/3. You got to reverse your inequality. Here it is a greater than inequality. You got to change it to a less than. And these are equivalent. Remember, the little alligator's hungry. The alligator's going to eat the bigger thing. Here it's eating the 4/3. Here it is also eating the 4/3. So those are equivalent statements. Now a quick application here. Example 8, dimensions of a container. So let's say you work in the marketing department of a soft drink company and you're experimenting with a new can for iced tea that's slightly narrower and taller than the standard can. For your experimental can, the ratio of the height to the radius is 4, as shown in the figure. We're going to do two things. Write the volume of the can as a function of R, and we're going to write the volume of the can as a function of H. So let's see here. We have to take into account this. The ratio of the height to the radius is 4. So if we have the radius, how do we get the height? Well, the radius is a little shorter. We have to multiply the radius by 4. 4 times the radius is equal to the height. Now we're going to do this in two separate ways. Part A, I'm just going to write the volume of a right cylinder. Volume equals pi r squared h. Pi r squared is a circle, that's the base of the can, times the height. And for part B, we're going to use the same thing. Volume equals pi r squared h. So let's see here. In part A, write the volume as a function of r. So we only want r's here. We want to replace this h with something. And what are we going to replace h with is 4r. So let's replace that h, r squared, this h with a 4 times r. And then let's clean this up a little bit. You know, I like to put my constants first, or my numbers, so the 4 goes first. Since we're multiplying everything here, we can just rearrange it. 4 goes first, and I'm going to put my pi, and then we have r squared times r to the first, which is r to the third. So there is the volume written as a function of the radius. Now, for part B, we're going to write the volume of the can as a function of h. So we want to get rid of the r. We want to replace that r with something. Well, let's come down here and solve this for r. Divide both sides by 4. r equals h divided by 4. So let's replace the r, pi. You know, we had an r squared times h. Let's replace that r with h over 4. Now let's clean this up a little bit. We're going to have our pi times h. And then when we square this, h over 4 squared is h squared over 16. And let's make this look a little prettier here. Let's see. If we multiply, you know, just straight across, these are both have a 1 under them. So pi times h squared is pi h to the third all over 16. And there we go. Let's see here. So a little summary of function terminology. A function is a relationship between two variables such that to each value of the independent variable there corresponds exactly one value of the dependent variable. And then we have our function notation. Y equals f of x. F is the name of the function. Remember, we've done g of x or h of x or whatever you want to call it. F, whatever that number is or that letter is in front, that's the name of the function. Y is the dependent variable. It depends on what you plug in for x. X is the independent variable. You know, when we were doing tables to graph functions of x's and y's, we would pick different x values and then plug them into the function to see what y values pops out. X is independent. Y depends on what value of x you put in. F of x is the value of the function for that particular value, x. Domain. The domain of a function is the set of all values or inputs of the independent variable for which the function is defined. If x is in the domain of the function f, f is said to be defined at x. If x is not in the domain of f, f is said to be undefined. Remember, just the biggie is domain or the inputs. Range. The range of the functions are the set of all values or outputs assumed by the dependent variable. That is the set of all function values. And then we have our implied domain. If f is defined by an algebraic expression and the domain is not specifically given to you, the implied domain consists of all real numbers for which the expression is defined. The big ones to remember for implied domain: don't divide by 0, and no negatives under even radicals. square roots, fourth roots, sixth roots, whatever. So some practice problems for you. The first one, find all values such that the function is equal to 0. 68, find the values which make those functions equal. And the last set there is find the domain of the function. Alright, pause the video, try the practice problems, and then fire it back up and see how you did. Let's see here. So the first one. F of x is 5x plus 1. We just want to set 5x plus 1 equal to 0. Subtract 1 from each side. 5x equals negative 1. Divide by 5, x is negative 1/5. If we plug negative 1/5 in right there, we'll get a negative 1 plus 1, which does in fact equal 0. So let's see here. The next one, 68. Find the x values which makes the functions equal. F of x equal to g of x. So they give us the functions, we just have to set them equal. So we're going to set this equal to 7x minus 5. I'm going to move everything to the left. So I am going to subtract a 7x, and I'm going to add a 5. That will take care of this side and make it equal to 0. And we have x squared. 2x minus 7x is minus 5x. 1 plus 5 is equal to positive 6. And then, is that going to turn out to be the exact same answers as one of our examples there? The factors of 6 that add up to negative 5. So that's negative 2 and negative 3. So x squared minus 5x plus 6. X squared minus 5x plus 6. That's the exact same thing from example 5. Oh, we sort of got a rerun. I'm sorry about that. I'll have to fix that for next year. Oh, but I guess, we were setting this equal to another function. It just happened to turn out that it turned out to be just like one of our examples. So it's all good. And this is equal to 0. So we set the first factor equal to 0, and we get x is 2. And we set the second function equal to 0, and we get x is 3. Those are the two x values that will set those two functions, f of x and g of x, equal to each other. The last three here are domains. And let's work from the bottom up. Here we have a third root of t plus 4. What's the domain of the function? They didn't specifically tell us what t values to use, so we should assume that any are viable. And should we be worried about negatives under an odd root, under a third root? Can you take the third root of negative 1? Well, yeah, that is negative 1, because negative 1 times itself does equal a negative 1. Negative times negative is positive, times another negative is negative. So for this one, for 76, t can be all real numbers. T equals all real numbers. We're only worried about negatives under even radicals. For the sake of argument, let's say that was a square root of t plus 4. Then we would take the t plus 4 under the radical and say, well, that must be greater than or equal to 0. It has to be positive. And then we would subtract 4 from each side and say t has to be greater than or equal to negative 4. Any other number less than that would give us a negative under the radical. For 74, s of y equals 3y over y plus 5, we got this quotient, a fraction. We're only ever worried about dividing by 0. So we want to take just the denominator, y plus 5, and say we do not want that to ever equal 0. So y plus 5 does not equal 0. Subtract 5 from each side. Y does not equal negative 5. Any other number is fine. Negative 5.1, negative 4.999 are fine. This is the one naughty number that will give us a divide by 0. And we don't want to divide by 0. 72. G of x equals 1 minus 2x squared. So let's think about this. Is there ever a chance of dividing by 0? No, we don't have a division at all, let alone a division with a variable in the denominator that could turn into a 0. So we don't have to worry about dividing by 0. Do we have any square roots or any other even roots at all? No, none. So here our domain will be all real numbers. There's no number that we cannot stick in there that will give us a good output. a true function value. Homework 422, page 197, this batch of problems. And now that I look at it, why didn't I give you any even problems here? Well, remember, you can always check your answers in the back of the book. If I do wind up collecting this assignment, I always want to see the work. Do not just copy the answers out of the back of the book. Copy down the problem and show me any work you need to do to get to the solution.